Hi, today we're going to talk about area of composite figures. These don't include circles. So we'll be discussing how to find area of a combined shape image. Remember that area is the amount of space that the shape covers. It's basically what is the space inside of a shape. Like if you wanted to paint the top of a table or put a tablecloth over something, those would be areas, examples of area. Area of an irregular shape is the total area of combined shapes. So when you take several different regular shapes, like a circle, a square, a triangle, or something, and you put it together, that makes a composite shape or an irregular shape. And what you want to do is you want to draw lines that will separate the irregular shape into regular shapes. You want to figure out where are the squares or rectangles in this shape. Find the area of those regular shapes, and then you're going to add or subtract them to find your total area. Let's do some practicing. Here we have an irregular shape, and we want to figure out what the total area is. I'd like for you guys to go ahead and create 4 boxes in your math notebook and draw this image in box number 1. We're going to go ahead and calculate together how to find the area. All right, well, when we look at this shape, you can cut it in several different ways. For me, the most common way would be to draw a line right there. When I draw a line right there, I see that I have area 1, which is a rectangle, and area 2, right here, which is a square. And I want to find the area of both of those parts and put them together to find the total area. So for area 1, I have a rectangle, and remember, area of a rectangle is length times width, and it does not matter whether you're using the 7 or the 8 for the length or which one you're using for the width. Because of commutative property, we know that the order that you multiply doesn't matter. So I'm going to go ahead and do 7 times 8. When I do that, I get 56. So the area of shape 1 is 56. And then the area of shape 2, which is a square, and a square is also similar to a rectangle, but we could use a little different formula. On our formula sheet, you would see that it's side square, and that's because we are doing the same thing as side times side. And our side is a 3, so 3 squared, or 3 times 3, and we get that it's 9. 56 and 9. So if we put the two together, if we do 56 and we add to it 9, our total area of this irregular shape is going to be 65 meters square. All right, so that would be the total area. Go ahead and add this to your math notebook. Great. Let's look at this shape. This will be in box number 2 of your math notebook. Again, now you can cut this in several different ways, but I'm going to look, for me, the most obvious way is to create a line right there. And we have area 1 and we have area 2. Now, because we have hatch marks, these lines that are on our shape, we know that those show congruency. So we know every time we see that matching hatch mark that all of those areas will have the same length measurement. So this is this is part number 1 that shows that the measurement of this is 5. So that means right here would be 5, and right here would be 5, and right here would be 5. Well, that helps because we can find the area of the first space easily. That would be length times width because it's a rectangle. And I'm going to use 13 times 5. Now, I know 13 times 10 is 130. So 13 times 5 is half of 10. So half of 130 is 65. So that's a quick way to do it if you didn't have a calculator. But certainly feel free to use your calculator if you need to. All right, so that's area 1. is 65 units. We don't know what the measurement is. Now, how do we use this to figure out what this area 2 is? It kind of looks like it's a square, but actually it's not. And here's how come we know that it's not going to be a square. We see that down here, the distance from this part to this part is 13, which would mean then that from this point right here all the way around to this point, and I just jumped over instead of drawing a straight line, that must also be 13. That should be congruent to this part that's opposite it. So, but what we already know is we know this part, which is 5, and we know this part, which is 5. So combined, that makes 10. Now, it looks like we want to make this a 2, but actually it can't be 2. It needs to be 3, and the reason why it's 3 is because we have 5, and 5 is 10, and the difference between that and 13 is 3. So we really, for area 2, have a rectangle, another rectangle, and that's going to be length times width again, which is 2 times 3, which is 6. And when we add these two together, 65 plus 6, we want to combine our space. We know that this is going to be 71. We're going to say units squared because we don't know what the measurement unit is. Okay, so let me put over here that this was 6. Go ahead and make sure you have this information in your math notebook. Excellent. All right, well, here we have a different shape. It kind of made it easy for us because they drew a dotted line in here to indicate what that two separate shapes are. So we have area 1, which is a rectangle, and we have area 2, which is a triangle. So here we go. Area 1, again, is length times width because of the rectangle. And now, don't be confused. We see a 9 on top and we see a 12 on bottom. So we have to determine, which one are we going to use? Well, we're really going to use this 9 and this 4 for the rectangle because we're measuring just this space right here. And this 12 goes from this section all the way down to this section right here. And since this area right here is not congruent up here on the top, then we know we can't use it, all right? So therefore, we are going to have to use 9 times 4. So 9 times 4, and that area for that space is 36. So space number 1, the area is 36 units. Well, therefore, that leaves area 2, which is a triangle, and we have to figure out what the measurements are. Well, several things that we can look at. The first one is this bottom number, since 12. All right, since it was 9 was on top, but 12's on the bottom, that must mean the difference between the 9 and the 12 is this space right here. So this space is going to be 3. So that space is 3. We need another part of our triangle. It is a right triangle, so we could use Pythagorean theorem, but we would need to have another measurement to do Pythagorean theorem. But we don't actually need to do this outside part because we're not doing perimeter. So we're going to use this 4. Since this line right here on our triangle is also congruent to the opposite line, which is the opposite part of our rectangle, that must be 4, so this side must be 4. So let's go ahead. Our formula for our triangle is 1/2 base times height, but we know we prefer to do base times height or length times width and divide it by 2 because really a triangle is half of a square or half of a rectangle, and that's what 1/2 is. 1/2 means we're actually dividing something and we're dividing it by 2. So our base in this case is 3. And our height of our triangle in this case is 4. And we're going to divide the whole thing by 2. So we have 12 divided by 2, which is now 6. And we want to combine the two areas. So this is 6. So if we have 36 and we have 6 more, we know that we have 42. And there's no units given, so we're just going to call it units squared. Squared because we're talking about area. Make sure you have this information into your box number 3 on your math notebook. All right, and then we have our final example. You're going to add this to box number 4. And again, they've done a very nice job of drawing in the lines to show us where it's separated. So this dotted line right down the middle or on the edge is going to show us that we have area 1, which is a rectangle, and another area which is another triangle. So area 1, the rectangle, is going to be length times width. And area 2, as we discovered in our last example, is going to be base times height divided by 2. Or if you're familiar with on your formula sheet, it would say 1/2 base times height. Okay, so for area number 1, the length and the width are going to be, we're going to use 6 times 3, and we will get 18 units. And then for our triangle, our height, or I'm sorry, our base is going to be the length of the rectangle. It's going to be the dotted line right here. So our base is going to be 6, and our height is going to be 2. And just a reminder that height on a triangle is always from the base to the tallest point of this triangle. So they did a great job of showing us what it is. So the height of this triangle is from the base to the tallest point, and they said that's 2, and we're going to divide it by 2, so we get 12 divided by 2, which is another measurement of 6. And when we add these two areas together, so area 1 was 18 units, area 2 is 6 units, so plus 6 over here, so our combined total is 24, and we don't know our units, we're going to say units squared. Always want to have some kind of a label on there. Excellent. Well, for your turn page, you have pages for your math notebook, and I want you to complete both of the example and the problems 1 and problems 2 for your flip notebook. That'll be in your math notebook. I want you to go back and review perimeter, add that to one section, and I want you to do the area problem as well. Complete those parts. And we will discuss your answers to these and any other questions you have in class.